Hello! In this episode of Finno-Ugric Machining, we are going on with, in last episode we made these 3 gears. Now we are going to make one more, this type of a gear. This is for the motor shaft. It's the sun gear in the middle. And then we will make the base in which the motor and these 3 gears attach to. So, and I believe this is more than enough for one episode. So, let's start right away. This is now the piece of material that is going to become the base of this cycloidic, cycloidic thing. I will first clean this surface. I'm peeling off 0.3 millimeters from here, and this is a cell mill which I have equipped with Cermet inserts. And we are running this at 300 RPM, and the feed is 70 millimeters per minute. So, let's start. Now I have turned this workpiece upside down. The surface became really nice. And then I have, as you can see, I have done some measuring here, so that now when I start cutting these, it will the thickness of this workpiece will become 19.3 millimeters. Our goal is 19 exactly, but that will the last 0.3 millimeters I will take off with the cell mill, because this one doesn't produce a good surface finish. But it's very effective on removing material, which we have to move quite a lot in this case. Unfortunately, I didn't have a more suitable piece for this one, so now I just mill this away. this is the final touch for this surface. I'm peeling off about 0.32 millimeters at one corner. This is has maybe 300ths of a millimeter thickness variation. So, but after this, it should be exactly 19 millimeters. Well, the surface, you definitely can see it, but you cannot feel it. Absolutely nothing here. Here in the very edge you can feel those two, but these are really faint. So I believe this surface is really flat. So next step, clean up the mess again. Well, this piece of material should be now made a little bit more rectangular. And now, this piece of paper is important. It serves here under, goes here under, and what it does, it increases the thickness. Well, I can manage with that one. And the surface finish is, well, of course, after that kind of milling, it's super. Okay, well, here is now the workpiece. I have done some cleanup for it. It has decent finish on it, and no wood, and so on. So I have now decided that this surface here will be our reference surface to this direction, so I mark it as such. So I will put this doesn't work always. It's really, now it did. Well, this side is the top side. We are not going to do that at this time. This is the underside. And here we have a picture what it will be like, and here are the dimensions and locations of these features. And in the underside we have a recess for the motor. Then we have 4 couples of M6 threads. They are for attaching the motor. And then we have a hole through. So this side is now tight and this is loose. There is a reason for that. So I wanted to pivot from this point when I straighten it. Until the needle moves to 0. When does it move? Now it moves. To 0. So the next operation will be a little bit of roughing. Well, this is now the other side. This was the side with this is the motor side. And this one will be now the one where we will be doing a lot of features. But the first thing is to get, you see, this is about the correct now. So this is a round thing which is 100 millimeters in diameter. It will be left to display. So, and the rest here around will be lower at 10 millimeters. So this is 19 millimeters thick, so 10 millimeters away. So I will first rough this portion here, from here. It's more than, this is 1-to-1 in relation, so we have 10 millimeters even more in this. So I will rough with my roughing end mill. This portion away, and the rest will be done by Volhauter. So I think that's how we do it. Okay, so finally I got this piece milled and now I have dialed this again in. Now it's standing on high, a little bit higher parallels, and it's really tightly clamped so it won't move. And then I also dialed this in using a dial indicator around the rim, the circle, so all the features within there must be concentric with this rim, so therefore this method. Okay, now I will drill a 9.9 millimeter hole through, and then I will ream it. Therefore I have this 30 millimeter gap there because I need to get this reamer entirely through. Well, now we have three very nice 10 millimeter holes there, hopefully in the correct places. And then the next step will be drill three more holes here. These will be for M8 bolt. And the tapping size for M8 would be, the tapping drill would be 6.8 millimeters. Well, I don't have that kind of drill, I have 6.5. But it's okay, I have tried this out, and it actually the minor diameter of M8 bolt is something like 6.45 or something. It's bigger than this drill, smaller than this drill. So this should be alright. It's a little bit tight to tap, but this is not very hard material, and I have very sharp M8 taps. And it's all the way through, so I can use a gun tap for this. So zip evacuation becomes no problem there. Okay, well, next it will be some Volhauter action. Let's put it this way, boring is so boring. So let's see now, this has to be installed here. That. Then we just tighten it. There you are. That's the first. It's a little bit oily, but it should be. Okay. Oh, wow, that slipping. Wow, okay. Wow. Size. The insert survived, but this didn't. Oh, we need to do the adjustment again. So here is now the base plate. Well, what I have here is, let me see if I can take this apart. There is some oil already. Oh, the oil has started to blacken. Okay, so this is just a 10 millimeter pin. Quite exact actually. So I try to position, and these are really tight. So I try to position them in a way that they should be in when they are really used. That's the orientation of those, and then this one more time there. And this really does have some oil. So, well, it's very tight. And I made a biofile slot there so that I could put this makeshift key there so that I can rotate this. So, does it rotate? Yeah, it does. Wait a minute, I will switch this on if I can. Oh. There you see. And yeah, so now these eccentrics are in sync. So this means when I put a plate there, it makes a rotational effect like this. And this is used to drive the actual gear, which is around here. But let's look a little bit nearer. Doesn't make a lot of sound. Well, yeah, it's. I was first suspecting that it's too tight, but I know it will. after some time it will wear in. After that it takes a very long time and then it wears out. But first it wears in. So, that's it. It was quite some task to do, and this time I made a few mistakes. What was the first mistake? Yeah, the first mistake was to not put the center, the peak bearing surface in the middle of the it was 0.4 millimeters off place. Well, the backslash in X direction in my table is 0.4 millimeters. So I strongly suspect that this was the reason for approaching the dimension from the from direction. Now it's all right. Only thing, it's no more 100 millimeters as planned. It's 97 point something, but it is totally usable. Next mistake. One of those three 10 millimeters holes where the gears sit is a little bit off place. I don't know what happened, but it is something like 0.1 millimeters off place. I was lucky enough that it is off place in such a way that it doesn't make this to bind. Okay, that was a second mistake. The third mistake, it's not a mistake. Yeah, it is a mistake. Was that when I was doing those recesses for the gears, my Wohlhaupter, the locking mechanism was not totally tightened. So it made, and I was running it really fast. So, oh wow, now there is a battle scar already in that one. But that one also doesn't impact the usability of this thing. Lucky there. Then the final mistake, which has some impact on this one, is that when I planned those planet gears there, I made it so that they are exactly on the pitch diameter distance from each other, from the sun gear. There should be some play. Whenever you do gears like this, you should plan some play there, 500ths of a millimeter at least, so that that they don't. Now they are so tight that they are really tight. But I know they will wear in.
It takes just some time. I need to rotate it there, and when it has done this, it probably takes 1 day. It's rotating there. The oil which I put there has already begun to become a little bit dark, means that there will be some metal particles floating around from the gears, I believe. So that's, well, okay. But of all these, none of these will impact the end usability of this thing. So I'm happy. It's not a perfect one. No, that's not a perfect one, but it's usable and very, at the moment I think it's very good actually. It's very tight, so no play at all. So, well, in the next episode of Finnogric Machining we are going to make the outer gear for this one. It's the one that comes around the whole thing. It's a little bit complex thing. There will be a lot of holes in it, teeth around the rim, etc. So it will be very nice thing to make. But that will be in the next episode of Finnogric Machining. Well, till then, bye!